Alright, so in this lesson we're going to work on how to write an equation for a sine or cosine graph. And really, sine and cosine graph, as you should have seen, look identical to each other except for the horizontal shift. So really, when we write these equations, for any function, we could really write a sine equation or a cosine equation. Okay? So we're going to look at the equation y equals a sine b of x minus c plus d. Again, sine could be replaced by cosine very easily. So some key things we should know, should have seen already from the graphing, that a stands for the amplitude. That again is the vertical shift, or the distance from the midline to the max, or the midline to the minimum, or it's really half of the total range values. Okay, b is the horizontal stretch. We can use b to get the period, or the period and b are connected. Period is equal to 2 pi over b. And we're really going to use that b, I'm going to actually change this up for this, we're going to use that b is equal to 2 pi over the period, because what we're going to be able to find from the graph is the period, and that's going to help us find the b value. Let's kind of reverse it a little bit. C is that horizontal shift, and then d is the midline, or the vertical shift. Alright, so those are some of the key things we should already know. So how am I going to write an equation then? Well, when I have the graph, the first thing I'm going to do is find the period. Okay. When I think period, I want to think max to max is one option, midline to two midlines. So I got to go over two midlines because it's going to hit it kind of twice on the way. Min to min also works. There's lots of options for how to find the period. I'm going to use that to find b. Okay, and again, b is equal to 2 pi over the period. So that's really what I'm going to do first. Second big thing I want to think about is find the amplitude of midline. So find a and d. And then third is really decide, cosine or sine and horizontal shift. Okay, so big things I want to do is going to find that period first and show you how to do that. We'll look max to max, midline to a couple midlines away, min to min, a couple different options. And we're really using that to find our b value. Then we're going to find the a and the d, which are pretty easy. That's our amplitude and our vertical shift, or midline. And then we're going to really determine, is this a sine or a cosine graph? Which one do I want to use? Again, it's really your choice. And then from that decision, we're going to determine the horizontal shift. Alright, so here's our first graph. Okay, so based on the first graph, first thing we said we're going to do is we're going to find the period. Okay, so how do we find the period? Okay, again, lots of different ways. Okay, the period is the distance from a max to the next max. Okay, all right. So now I got to kind of figure out how much, is that? Okay, or I can go. Another option is, picking really any starting point. Well, that's not bad. I mean, I'm going to have to do some math to kind of figure out what this x value is and what this x value is. Okay. Another option is to start right on the axes, which is right there. Okay, so I'm going up, going down. I want to get back to the exact same place I started, which would be right there and right there. That's kind of one full cycle. Oh, that's perfect. That's 0 to 2 pi. Okay, so my period equals 2 pi. Okay. So again, one of the easiest things I think almost is to start right on your x-axis and then trace, or on your y-axis, sorry, and trace until you get back to that exact same spot. So you've covered one full cycle of the graph. Look to see where the x value is that you ended at, and that's your period. All right, why did we know that? Well, we wanted to know that so that we could find b. So remember, b is equal to 2 pi over the period, which is 2 pi. So our b value is just 1. Okay, that's good. Remember, we're trying to write the equation y equals a sine or cosine b, then x minus c plus d. All right. Next thing we said we wanted to find that a and that d value. Okay, so let's come back to our graph. And here's our maximum. So our maximum is right up there. Our minimum is down here. And our midline is going to be in the middle of that. So let's figure out where we're at. This is at a height of 3, and this is down at -1. So the middle of 3 and -1, those are 4 units away. So the middle is going to be at 1. So you can kind of think about, there's my midline. Okay, that means D is 1. So D is my midline. And then my amplitude, remember we said, is the distance from the midline up to a max. So if I'm at 1 and I go up to 3, that means I went up 2. So A is 2. All right. So I got A to be 2 and D to be 1. All right, so I know B, A, and D. I'm left now to find C. All right, so we're almost done with our equation. So let's come back. All right, so last piece we said is we need to decide, which function we're going to use, sine or cosine. Okay, I'm going to do both. So I'm going to kind of use, let's get rid of some of this stuff so I can see this picture a little bit better. If I chose cosine, I'd be looking for a maximum, which is right there. Okay, a lot of people like cosines because they're maximums and they're kind of easy to see. So I need to figure out how far that's been shifted. Well, cosine starts at a max, so it would have been there, and it's been shifted to the right a certain amount of units. Well, all the way out to here is pi, so the middle of that would be pi over 2, so that would be a pi over 4. So this spot, which is where my cosine max is 3 pi over 4. So it must have been shifted to the right 3 pi over 4. Okay, so C is 3 pi over 4, and it's to the right. All right, this is if I did cosine. So I should have my equation then. Y equals A is 2 cosine. B was 1, so I don't really need that in there. X, and it was to the right, so minus 3 pi over 4, and then plus D. There's one possible equation, and that's if I chose cosine. Now there's an infinite number of possibilities, but these are kind of your basic ones to pick. All right, let's go back and let's see if we chose sine instead. Sine is the midline. Well, here's that midline in blue here. So sines start at a midline and go up. Yep, that spot right there is a midline, and the graph goes up from there. That is to the right, pi over 4. Okay, so if I chose sine, I'd have similar equation, y equals still 2, this time sine, to the right pi over 4 plus 1. So there would be an equation for sine. And again, notice they kind of differ by pi over 2, which is sort of what that shift is. So there are your two equations, amplitude of 2 shifted to the right, either pi over 4 for a sine graph, or 3 pi over 4 for a cosine graph, and then the midline is up at 1. Let's look at the second equation here. All right, so here's this graph. So again, I want to try to find the period first. So I'm going to start tracing. Again, I said it's a good suggestion would be to trace starting on the y-axis and go until I get back to the exact same spot, which is right there. That looks like one full cycle. If I picked that blue piece up, if I copied it and picked it up, it would be able to set down and kind of start another picture right with that. All right, so how far did I go over? Pi. So the period in this case is just pi. Okay, so how did I use that? Remember, we found b to equal 2 pi over the period. 2 pi over pi is 2. So my b value for this equation is 2. All right, second thing we wanted to find is that midline and the amplitude. So when I come back here, I'm going to take a look. We got a maximum up here, minimum down here. So that's 0 and -2. And the middle of that would be at -1. So D equals -1. And then remember, the A is the distance from the midline to the max. So when I go from -1 up to 0, I'm traveling 1 unit. So A is 1. Okay, so I know A is 1 and D is -1. All right, let's write that down. A equals 1, D equals -1. All right, so last thing is determine again, sine or cosine, and then figure out what we should be using for our max or our min then. All right, so if we decided to use a cosine, we'd be focusing on, let me again kind of erase some of this stuff. Get back to this picture of the graph. There we go, looks better. If we did a cosine, we'd be looking for the maximum, which is right there. All right, how much did that move? Well, we've got pi, which is right here. So this is pi over 2. So this must be pi over 4. Okay, so a cosine graph, looking at the maximum, the graph was shifted to the right, pi over 4. Okay, sounds good. So C is pi over 4 to the right. Alright, so let's write our cosine equation then. It's going to be y equals A, which is 1. Don't really need it then. Cosine, my B value is 2, parenthesis, x minus, right, pi over 4, and then du is -1. So there's one possible equation for cosine. Let's see about sine. Sine starts at a midline. Well, my midline was down here at -1, and the graph starts exactly at the midline. So sine actually would have been kind of the smarter choice for my equation here. So there's no shift then. So it's just y equals sine of 2x minus 1. You could have just written this y equals sine 2x minus 1, capital parentheses if you want. Either one of those, two are okay equations to write. So no horizontal shift at all for the sine graph because it started right on the midline. Some people really like to use cosine because it's just easier to find the max than it is to find, maybe the midline, but both will work for you. All right, so one last one that's a little bit different. So you notice this last one, the horizontal scale is not in terms of pies. It's actually, more numerical or integer values, which is important for some real life situations, things like that you're going to have to model. So again, no difference from what we're going to do. We're going to find our period first. So again, I'm going to start at the x-axis or y-axis and kind of trace, coming down, coming back up. Right there, there's kind of where I make one full cycle. How far out is that? Well, there's 5, there's 6, there's 7, there's 8. Okay, so my period is 8. Okay, so period is 8. Okay, that's okay, no problem. Remember, B is equal to 2 pi divided by your period. So 2 pi divided by 8, I can reduce. That's a 2 times a 4, so the 2's cancel. So I'm left with pi over 4. No big deal. So B is pi over 4. So this time, instead of being the number 2 or a half, it's actually in terms of pi. All right, let's come back and find our amplitude and our midline. So again, let's find our max. Max is up here. That looks like it's at 4. Minimum down here at -2. That's a total of 6 units away. Right? -2 to 0 is 2 plus 4 more, so that's 6 units. So the middle should be 3 away. 1, 2, 3. So the midline should be right there at a height of 1. So D equals 1. And again, our amplitude is the distance from the midline to a max. So A equals 3. 3 units up gets you to 4, 3 units down gets you to negative 2. Alright, so we found D equal 1 and A equal 3. And so then finally we got that sine or cosine, looking at the max or the midline, and then looking at that horizontal shift. Alright, so let's again erase so I can see some stuff better. Alright, let's go with cosine first. That's what we've been kind of focusing in on. So I go cosine, there's my max. My max is over 1, 2, 3. So right 3 for cosine. That's going to do cosine right 3. So C is 3 to the right. Alright, so my cosine equation should look like y equals 3 from A, and then cosine pi over 4, and x minus C, which was 3 to the right, so it's a minus 3, and D was plus 1. There's your equation. Alright, let's do sine. Sine is the midline. So my midline is right there. So midline is the right one. Okay, so there's a right one. So midline C would be right one for a sine. So my sine equation would look like y equals 3 cosine pi over 4 x minus 1 plus 1. Oops, sorry, I screwed up on that. This was the midline, this was my sine. My apologies. So there's the equation for that. Okay. I'm just going to do 2 more equations quickly from this same graph, just to show you that there's lots of different options for it. If for whatever reason I decided to pick maybe this spot down here, this would be a minimum. Okay. So if I started at a minimum, I could think about it being like a reflected cosine. Okay. And then this would then actually to the left one. So I've got like a reflected cosine. That's left one. Okay, reflected cosine, left one. All right, let's remember that. Okay. So if I want to do a reflected cosine means I need a negative in there, and left one means this needs to turn into a plus 1. So that equation actually is also going to make that graph. It flips it, so I'm starting at a minimum versus a maximum, and then the minimum was to the left one. Okay. If I do the same idea with a sine, I could think about, yeah, I want the midline, but the graph actually goes down. Okay. So if the graph goes down, then it's a reflected sine. Okay. And then, whereas this point, it looks like it's 3 to the left. Okay, so we're looking at, left 3 and reflected sine. So on the left 3 reflected sine. So let's put a negative out here to reflect it, and then left 3 would turn this into plus 3. Okay. So all 4 of those equations are identical equations. They all make the exact same graph. These are just 4 equations. Again, there's an infinite number of equations that would make this sketch, but those are just the ones I kind of wanted to think about. So keep in mind, it's okay that it's not in pi values for your x tick marks. That could be in integer values as well. You just end up with something maybe in terms of pi, or a decimal approximation would be, fine as well. And then the other key things to think about is, again, if it goes downhill first, you might think about using a negative sign. If you focus in on, I want to start at a minimum versus at a maximum for whatever reason, then I could use a reflected,